we are from AS125. This is our video assessment for Mat183. This is my group member. There are Wardina Amani binti Hasdi, Nur Nadia Dini binti Kasim, and me, Nurul Nadira binti Rashid. We are from AS125 2B. In this video, you will see an introduction for differentiation, the problem statement, and the problem solution.
Hi, my name is Nurdania Dini, and today I will be talking about introductions for application of differentiation. There are many of the application problems in calculus involve function, which you must find maximum or minimum values. The restrictions that were stated on the question or implied for the function will then determine the domain which you must work. Both the function with its domain will then suggest which technique is suitable to apply in determining the maximum or minimum values. Optimization problem is also known as applied maximum or minimum problems in calculus. It involves finding the largest or smallest value of a function within the given context. In various fields such as engineering, physics, and biology, this problem has been prevalent where optimal solutions are sought under particular constraints. Solving this calculus problem requires in understanding the situation, formulating a mathematical model, and using calculus to find the optimal solution. Thus, applied maximum or minimum problems helps in enhancing one's analytical skills.
The title that we use for this problem is Special Gift for a Special Person. This is Alia. She wants to make a birthday gift for her mom. Next part will show the problem statement. This is the problem statement. Alia wants to make a cuboid shape of gift box to put a bracelet for her mom's birthday. The volume of it is 63 cm3. Given that the length of the gift box is twice its width. The material of gift box that Alia used is cardboard, and the cost of the cardboard is 10 cents per cm square. Alia would like to know the minimum cost for her to make the gift box for her mom's birthday. To help us more, Alia already gave us the sketch for the box. From the problem statement, we can take out the information, which is the volume of the box is 63 cm3, the cost of the cardboard is Rm 10 cents, and the length is twice its width. To solve this question, we need to understand the information given. X is a width and Y is a length. Since in the question say length twice its width, so length is a y equals to 2x. Second step, we need to find a height since it's not given in the problem. We will use the formula volume of a cuboid, which is length times width times height equals to volume. Next, we will use the formula surface of a cuboid. Next, to find the cost of a cardboard, we just times the cost of the cardboard per cm square with the previous answer. To continue the solution, we need to differentiate c with respect to x. After differentiate c with respect to x, we will get dc dx. So we will let dc dx equals to 0 to find x, which is the width. After that, we differentiate again, which is we use the second derivative test to make sure the cost is minimum. From the previous calculation, we can see that the cost is minimum, which is a positive value, and the x value that we got in the previous is 2.94, so we just insert the value of x into the cost that we already calculated before, and we got the cost of cardboard per cm square is Rm 10 ringgit 40 cents. So we already have Alia to solve this problem by knowing the minimum cost per cm square of the cardboard, which is Rm 10 ringgit 40 cents.
Thank you, Dania and Nadira, for the first part and the second half of the video. So now you have reached the final part of the video, which is the conclusion. So I will be telling you guys the conclusion that we conclude. from this whole video. We conclude that applying differentiation involves using the rules of calculus to analyze function and their behavior. Here's a summary of how it's applied. Firstly, finding derivatives. Differentiation is primarily used to find the derivative of a function, which represents its rate of change. For example, for a function f(x), the derivative f prime x or df over dx tell us how f(x) change with respect to x. Secondly, we conclude that optimization. Derivatives help in finding maximum and minimum points of a function. For instance, to maximize or minimize a function, f(x), you find where f prime x is equal to 0 and check the second derivative to confirm whether it's maximum or minimum. And thirdly, we conclude that rates of change. Derivative can also represent rates of change in real-world scenarios. As shown in the video, it's applied in our daily life without our knowing. Moreover, we conclude that related rates, which is in problem involving multiple variables changing with respect to time or another variable, differentiation helps find how these rates are related. Lastly, which is higher derivatives, like beyond first derivatives, second derivatives, and higher, provide information about the curvature and concavity of functions. Therefore, we conclude that applying differentiation involves understanding these concepts and using appropriate rules like the power rules, product rule, chain rule to solve specific problems in calculate and real-world applications. And that's all from me. Thank you.
That's all from us. Thank you for watching.